In today's lesson, we're going to be talking about matrices and system of linear equations. So a matrix is actually kind of a rectangular array of numbers where it has a certain number of rows and a certain number of columns. If you're looking at a specific entry, and it will be written as A sub ij, where the I is a row and j is the column it's in. So what we're really going to be using here today is the augmented matrix. So we're actually going to take a system of equations and move it into a matrix, kind of like the example below. To be able to solve system of equations when it's in an augmented matrix, we need to use row echelon or reduced row echelon form of a matrix. And so to do that, we need to meet certain requirements. So the first three, the first non-zero number in each row from left to right is a 1. That's the leading entry. The leading entry in each row is to the right of the leading entry in the row above it. And if there's a row of all zeros, those just need to be at the bottom. Something we'll work on in the next lesson is reduced row echelon form, where we meet this last requirement where every number above and below the leading entry of your row is a 0. But to focus on how to get it there, we have 3 different row operations. So you can add a multiple to one row to another. You can multiply a row by a non-zero constant, or you can actually switch rows. And so in this process of doing this is called Gaussian elimination. So first things first, we need to take our equation and put it into an augmented matrix. So I'm just writing the coefficients of each of these. So the top one is just 1, -1, 3, and 4. No equal signs, no y's, no z's, no x's. Okay. Second row is the second equation, and the third row is the third equation. Then from there, I need to put my equations into this idea. So the first number in the first row needs to be a 1, which it is already. So I don't have to worry about that one. But the things below it need to end up being zeros, because I can't have a leading entry of a 1 underneath my first leading entry. Okay, so the top left corner will always be a 1, and then it'll kind of go diagonally from there. So the second row, second column will be a 1, and then the third row, third column should be a 1. So we're kind of going for that kind of pattern. So to get the second row first entry or first column to be a 0, you actually multiply the top equation or the top row by kind of like the additive opposite, so which would be -1, and then I add it to row 2. Now notice I'm not changing the top row, I'm just applying something and then adding it to row 2. It's kind of like what we do when we're using elimination. We're creating a new equation, and that new equation is actually written in the row where we write at the end. So that's how I got 0, 3, -5, 6 for that second entry there. And then I do the same thing to get the 3 in the last row to be a 0. So I multiply the top row by -3 and then add it to row 3 to get that equation. But that also does it to everything else. So each column is changed based on what you do to that row, because you're adding the entire row to another row. Okay. Now I want the first entry in the second row to be a 1. So that's that second row, second column. To do that, it's a 3 to begin with, so I multiply by 1/3. That makes everything else change. And then I want the thing below that 1 to be a 0, so that 2 needs to be a 0. So I multiply the second row by -2 and then add it to row 3 to get that 2 to be a 0, which changes the other columns. Okay, so then now the last thing I need to do is make that -2/3 in the last row a 1. So I multiply by the reciprocal. So that's where I'm getting 3 over 2. That's how I got the 1/3 in the last one. It's because the reciprocal of 3 is 1/3. So in doing so, negative 2/3 becomes a 1, and then that'll change my negative 2 into a positive 3. Okay, so then now I can actually take this stuff out and write it as a system of equations again. And then I can solve. So plugging in the z got me y equals 7. Then plugging in both gets me x equals 2. And so then I have my order triple of 2, 7, 3 is my answer. Another example, so remember, first thing I do is put in an augmented matrix. So first equation's the top row, second equation's the second row, and the third equation's the bottom row. So then from here, I want that top row to be a 1 in the first row, first column, so I multiply by the reciprocal, which is 1/4. And that changes that row, and then I write the other rows. Okay, now I want that 3 to be a 0, so I'll multiply the top row by negative 3, so the additive opposite, and then add it to the second row. Then for my next one, I want the negative 5 to go away. So I'll multiply the top row by 5, and then add it to the third row. Okay. Then the second row, second column, I want that to be a 1, so I'll multiply the second row by 1/2. Luckily, all those values are even, so I don't have any fractions here. And then I will multiply the second row by negative 5 to get rid of the 5 in the third row. Also know that, like in the first example that we did, it's okay to have fractions, so don't let that throw you off, because that'll happen sometimes. Then the last operation here, I want to multiply by the reciprocal in the third row of negative 10, which is negative 1/10. And then that works out pretty nicely since they're both divisible by 10. So now I'm pulling them out to be able to use my back substitution to help me solve. So I have z equals negative 2 here. I use that to help me find y, which is 1. And then use both those values to help me find x, which will be negative 3. Hopefully you found this video to be helpful. Thanks for watching.